All right. Thank you all for joining our webinar today. It's not easy with all this online events, so we really appreciate your patience and and giving us 1 hour of your time to be with us today. And hopefully, we will all go home having learned something useful to help with whatever the current initiatives that we have at our workplaces. So I'm Rajat Atpattu. I'm the CTO for Randoli. Prior to joining Randoli, I was at Red Hat for about 9 years. 11 years. About 9 years in engineering. Building middleware products, and then moved on to consulting as an enterprise architect. And then, of course, I started Randoli with a partner, and we've been working close with Red Hat ever since as business partners. Um, all right, cool. So I kind of wanted to give you a bit of a flavor of what we have been doing with application modernization before we kind of look at the agenda and get going. For the last couple of years, we've been doing a number of engagements. We've done a number of engagements, both small scale projects to very large scale transformation projects that we've been part of. Anywhere from 3 months to 2 years with with our customers. We currently have about 7 engagements all related to application modernization. About 4 of them we are kind of leading the charge, providing thought leadership and consulting. And for some of these engagements, we are also providing software delivery services, so kind of like giving the full experience there. I also wanted to take right off the bat a little bit of time to talk about our go-to toolkit, like the technologies that we use typically in a modernization project, and these technologies have been used in the last couple of years with a lot of success. And very happy and proud to kind of talk about this because we've been part of some of these technologies as well. We've used Apache Camel with either Spring Boot or Quarkus to build our microservices. We've had a lot of success with that because almost every microservice project is an integration problem at underneath the covers. It's really an integration project. There's a lot of integration issues you have to deal with, so it really shines, and that's our go-to toolkit when we build microservices using Java. It's available from the Red Hat integration portfolio. Almost every project we've dealt with, there is some form of messaging involved. So Kafka or AMQ, that is also again part of the Red Hat integration portfolio. Red Hat Data Grid, we're currently actually helping IBM with a large modernization project for a telecom provider where they are using Data Grid. It's available as part of the Red Hat runtimes. Almost all of those modernization efforts have been deployed on Kubernetes or Red Hat OpenShift, which is our preferred or recommended platform. And a couple of other, I'd say, key technologies that that has helped us to put together the overall solution. Keycloak being the identity and access management part that's available as part of the Red Hat runtime, so with OpenShift itself. Tekton is the cloud native build pipeline, so it's not just your applications have to be cloud native. You definitely want your build system to also be cloud. We'll talk a little bit about that later on, and that's offered through the OpenShift pipelines. And we are beginning to see a specialization between CI versus CD. So we end up using Tekton for the continuous integration piece and Argo CD for the continuous delivery piece. That's available as part of the Red Hat GitHub's portfolio. So GitHub's offering. So all of those below Kubernetes or rather this Red Hat OpenShift, they're all included with your Red Hat OpenShift subscription. Right, cool. So now that's out of the way. Let's Let's quickly go through the agenda. We'll talk about why cloud native. I'll use 3 stories to kind of really highlight the benefits, and in some cases, how it hurt when it was, because those applications were not cloud native. We'll talk about taking a phased approach to modernization. We'll walk through our flagship case study. And then I want to talk about some patterns that has helped us over the years. There's a lot of patterns out there if you read about it. Not enough time to talk about everything, but just wanted to talk about some patterns and strategies that have really helped us make our modernization project very successful. Right, cool. So why cloud native? And I want to take you through 3 stories. So the first story is also a flagship case study for today. This postal technology company wanted to make sure that they are able to meet the demands come Black Friday, and every year it was a bit of a trying to catch up and kind of hope for the best. It took weeks to add, or sometimes months to add capacity. Legacy applications pretty slow, costly, took a lot of time to push fixes, and there's a lot of manual deployment as well. Now, I was involved with this particular company prior to this project, so I experienced some of these things firsthand myself. And when we took on this migrate, or rather the modernization project, we worked together to move to microservices and on OpenShift, and provide that ability to scale up within seconds. But what I really wanted to highlight in this story is not the fact that we were able to scale up within seconds. It's important, and the fact that we also got a lot of much better performance with way less resources at a pretty low cost is also worth highlighting. But what I really want to talk about was just before the first phase went to production, that was in May, and now the second phase is just about to go to production. During that first phase, closer to production, we identified 2 issues during performance testing. And one of those was an issue related to SQL Server, which needed a fix on the SQL Server side and on one of the applicate or one of the microservices. The other was we found an obscure bug in Camel Netty component that we ended up putting a fix in and providing a patch upstream. And we were able to resolve all of this within about 3 to 4 weeks. And the real reason why we were able to do it with confidence was the fact that we were able to run the tests at scale in a repeatable fashion. And also the fact that that change is isolated to a particular microservice. So if we didn't have microservices, and if we didn't have the ability to run the tests at scale, we will not be able to resolve those issues quickly and meet those timelines and get those features into production with confidence. And then that's a pretty good story about why cloud native matters, because compared to the existing situation, that would have taken months. So the fact that it was containerized, microservices, and the ability to run at scale, your tests really saved the day, and we were able to push it into production. Now, come phase 2, we're looking very good, and the real litmus test will come very close to Black Friday, or rather on Black Friday and then the holiday season. Now compare that with this, another Black Friday story. This was a credit card transaction processing company. We were I was asked to come and help them scale their messaging infrastructure, and during the conversations, it was pretty obvious that some of the applications that end up using this messaging tier was going to become a bottleneck because they were monoliths, but only certain parts of it was required to have extra capacity to meet the demands. But they had no choice but to take the entire application stack and replicate it across. And they had to go they had to overestimate just to be on the safe side, because it wasn't really possible to do it very, very quickly. Had they been microservices, had they been containerized, if they were cloud native applications, the story would have been a lot better. So two Black Friday stories, two very different outcomes. Hopefully, that can help you realize why cloud native matters. And we'll talk about the third one. This is at a Canadian bank. And, one of the things that I'd like to say is that if you want to deploy at scale, you should be able to test at scale. This was, we were the first to introduce microservices at this bank. We knew this because the enterprise architecture group came in, spoke to myself and John, who was the other architect at the time. And we migrated their credit application portfolio from a monolith into microservices. But at the time, OpenShift was just about being introduced there. And they still wanted to go with VM-based approach. Again, we were trying to do our very best with the given situation. And 8 weeks later, we did a production release. 8 weeks later, the pre-prod testing teams comes and says, "Oh, there is a performance issue." Now, it just so happened around the same time, we were to do a POC and present the findings to the VP and the AVP. So myself and John, we decided to take our integration tests and run it for a longer duration on OpenShift. So as part of the POC, we took some of those microservices and deployed onto OpenShift. And the testing, we hooked it up to a Jenkins pipeline, and that was supposed to run nightly. And we ran those integration tests for a longer period. Lo and behold, we come the next day, we were able to reproduce that issue within about 5 hours. Now, the real reason why this couldn't be done was not due to lack of infrastructure or anything else, but the dev team really had no ability to run these performance tests. Another thing was that to figure out the details between the dev team and the pre-production testing team, it took a good 2 days to really tease out all the details. So there was a bit of a gap because the teams were operating in silos. There was no real good collaboration. Teams were throwing things over the wall, and not having that ability to work together to kind of get these all to get these performance tests and get that feedback loop going. Now compare and contrast that with the postal technology company. The developers are able to see the results of the performance test. They are because of the OpenShift platform, they do have some read-only access. They can see what's happening in the pods. They can see the performance metrics. They can see what's happening, and the ability to kind of run these performance tests repeatedly. So this will help you. I mean, if they enable this kind of automation on the right platform, they want to do microservices, but had they gone that extra mile and got this going, they would have figured out this issue, not in 8 weeks, but perhaps the next day, or if you run, even if you run weekly, within a couple of days. So that's what cloud native brings to the table. And I also want to spend a minute on the cross collaboration part. And one of the reasons why the whole effort fell apart later on is the fact that the people were not on board. The people were not part of the modernization story over here at the bank. So that the fact that there's no collaboration, there's no sense of shared ownership, meant that there was nobody who was taking ownership of how these up, who's going to test the update, who's going to run. So that whole effort fell apart. Now compare that with the postal technology company. There was a team that really championed this effort, and they helped the developers, they coached the developers, they provided a lot of guidance and enabled the developers to automate their tests, to run those performance tests, to the ability to do a lot of these things themselves instead of having to rely on some other team. So that feedback loop was a lot faster. That really enabled the customer to get this into production really quickly. Sorry about that. Since suddenly I found my laptop not plugged in, and I was just about to lose power, and I was freaking out. Anyways, so getting back to where we were, hopefully these stories would have helped you figure out why cloud native matters and how it would have made a difference had they've used some of the main pillars of what cloud native is in those applications. So yes, and we talked about all of these main pillars during those 3 case studies. It should have been pretty obvious by now that automation was a key in the success and was a key reason why it failed in the other use case. The whole DevOps culture is another key difference between the successful case and the one that was not so successful case. The ability to containerize applications, I can't stress enough of that. The fact that you can take that same immutable image and graduate it across multiple environments from, in the case of the postal technology company, the same image that was tested on QA, staging, perf, pre-prod to prod, really gave the team and the decision makers the confidence to throw it into production with a lot of confidence when, without having to kind of second guess, is this going to work, etc. We worked with some very aggressive timelines without the fact that we had microservices and containers. I really don't think we would have achieved those business outcomes given those timelines. All right, cool. So let's talk a little bit about putting together a cloud native strategy. And after working with customers over the last couple of years, I kind of want to call out certain points because I feel like there is some misconception out there and misunderstandings. You don't need all your workloads to run on a public cloud to be cloud native. You can jolly well run them on a on-prem private cloud, and that's where OpenShift really shines. You don't have to be tied to any one cloud vendor, including Red Hat, as long as you build your applications using standards out there. You should be able to use any cloud vendor. And the next one is something that this whole cloud first versus cloud smart is something that a lot of customers tend to learn the hard way. When you start with, you think, cloud first for everything. Okay, let's throw everything into the cloud. Let's try to containerize everything. And then later on, you realize that not everything is supposed to be containerized or moved to the cloud. And not every application can be thrown into the cloud. So then you kind of shift your strategy to become a little bit more cloud smart, right? So I urge to think hybrid. That has worked very well for most of our customers, because for some workloads, they have to be run where the data and the other applications are. For example, for the same postal technology company, we are looking at modernizing a very old legacy data transformation type of application that's out there. Lots of legacy data formats that are being fed by legacy systems. And when we did the assessment and looked at this in detail, we realized that it would take a lot of cost and a lot of effort to move the data into the cloud and back if we throw everything into the cloud, right? I'm talking about public cloud. So, the smarter approach was to run this application on an on-prem cloud platform like OpenShift, where the applications that are processing this data is closer to where the data is, and the other applications that are feeding in or reading the output from these transformations. And security was also a constraint. So you'll find that you'd have to almost always adapt a hybrid strategy, because not everything can be moved onto the public cloud. And this is where, again, I think OpenShift is a great platform, because it can provide that uniform experience across your private and public clouds. All majority of the major cloud vendors now have a managed OpenShift offering. So it's a great place to start with if you're thinking about a hybrid strategy. And more often than not, if you're a larger organization with a lot of applications, you'd have to almost think of hybrid approach because of these reasons that I just talked about. Right. Okay, cool. Now let's look at how to craft a modernization strategy. Now, almost always you'd realize that when you take on a modernization effort, very rarely you are able to take a big bang approach and start with a clean slate. 99% of the time that's not possible. So the old and the new has to coexist at least for a certain period of time. So you'd have to think about that, and you have to plan for that, and make sure that that's accounted for in your modernization strategy. So what we typically recommend is a phased approach, right? You start with an assessment phase where you do a discovery session. You look at the existing applications, you look at the existing architecture, and try to come up with the target state architecture. What we found helpful in some of these exercises is the Red Hat Migration Toolkit. For example, we are currently helping a large aircraft manufacturer to look at the entire Java application portfolio and provide recommendations on how best to evolve those applications, whether they should be migrated, whether they should be modernized, or whether they can be replaced. Now, obviously, in order to do that, you'd have to work hand in hand with the business, because a lot of these decisions are also dictated by the business. It has to make sense from a business perspective. You have to be able to justify the business value of it. All our successful modernization projects started with this phase, because you really need to take a hard look at what you have and figure out. And this is also where you have to plan how your legacy and the new how they're going to coexist, and how it's going to impact your customers. What's your customer experience going to look like while you have these two systems, and then what is your strategy for moving your customers from eventually moving your customers from your legacy platform into the new platform. So you have to really think about from a customer perspective too. It's not just a matter of just moving to microservices without thinking through that. The next step is to, now that you've gone through the assessment phase, you've identified certain things, you've worked out the architecture, think about containerizing. So if you haven't done that before, one easy way to start is think about, can your monolith be contained? Now, some cases you can, and it doesn't make sense, but in some cases you can. We are working with a land registry system, an organization that runs a land registry system, and they took this approach. So one of the first things they did was, after realizing that they may not get the full benefits, but at least they can containerize it and plug in the automation, they can get some benefit out of it, and they already have their monolith in OpenShift running, and it also gave them a quick way to kind of figure out some of the processes and procedures around and policies around how we want to craft your containerization strategy, right? Like getting all the support costs together. So along with that, and that's why it's kind of like a stacked approach here, you want to think about how you want to move to microservices. One option and a recommended option is, if you're building new services or features or capabilities, think about building them as microservices, so you're not adding to the legacy pile and increasing your technical debt, right? So think about how you want to move your new features into microservices, and at the same time think about how you can move your existing capabilities piecemeal into the into microservices as well, right? This kind of helps you to have that kind of like that hybrid approach where your legacy and your new services are going to start to coexist, right? And this is where the strangler fig and the anti-corruption layer pattern comes into play. I'll talk about that in a second. So this can then, now you can start, moving new customers to use some of these new services. At the same time, continue to support your legacy customers so they have some time before they can migrate to the new set of API. And there may be some customers that, for certain reasons, may never migrate off. So your legacy applications, your monolith, may have to end up living for a reason, indefinitely in some cases. But most cases, you might be able to slowly starve it, and eventually your microservices footprint will grow, and your legacy will start to shrink step by step. Before I talk about the strangler fig pattern, I want to quickly talk a little bit about some of the technology that can help you in this phased approach. Obviously, when you talk about containerization and automation, OpenShift is a great platform. Tecton provides those cloud-native CI pipelines that can really help you with your automation tasks. And when you're building microservices, I already talked about Apache Camel with Spring Boot or Quarkus that comes with the Redis integration. And then in order to support this strangler fig and anti-corruption layer pattern, 3-scale API gateway can be used. We are currently using that with the land registry company, where we are supporting both the legacy and the new using the 3-scale API gateway. And this is what the strangler fig pattern looks like. For those of you who are not familiar, a strangler fig is this gigantic tree where it starts this other branches or roots starts to come down, and they start to grow, eventually kind of like strangling the mother tree, right? So it's essentially the same kind of approach here, where when we start, we have the big monolith, and then we move maybe a new feature, or it could be an existing feature that we've started moving. And as you go through the different stages, you start adding more and more services as microservices, and your monolith footprint starts to get smaller and smaller, and eventually you can completely phase it out. Or it could be that certain applications can continue to use the monolith because your customers can't support it. There was a question. Do you mind if I take the questions at the end? John, I guess that's you. You raised your hand, but rest assured I will answer your question at the end. And if not, I'm happy to have a follow-up conversation with you to make sure I answer all your questions. Cool. Right. So more often than not, you would see that you would have to use this pattern because of because of all the other constraints around the business and making sure there's less disruption for your customers. And John, do you mind typing your question on the questions list? I know you raised your hand. It'll help me if you can, so I can, if it's something that is quick, I can answer, but if not, I will answer right at the end. All right, so cool. Now, talking about the, using, how do you, we talked about the strangler fig pattern, but how do you make sure the legacy and the new coexist, right? So one strategy is to kind of use an API gateway that will route to either of those applications. For certain features you route to the monolith. For certain features you route to your new set of services. Now, in practice, this is easier said than done. So and you'd almost always have to come up with some other strategies to kind of help, right? And for example, with the land registry company, where they have a SOAP interface, and all their customers are using the SOAP interface. And now we have the new microservices that we are building. It doesn't make sense to use SOAP, so we're using REST. Now, until new customers, for their new customers, they plan to use the REST interfaces, but for the existing customers, you have to support the SOAP services. And what they want to do is to eventually phase out the monolith. So we have a translation layer. So we have a Camel 3-scale custom policy for the 3-scale API gateway that will do a translation from SOAP into REST. So all the existing customers still have a way to continue until they fully migrate off. New customers will directly use the REST interfaces. And over a period of time, hopefully, they are able to get to the target state. Right. Jose, I saw your questions, and I'll talk about that. During the patterns, that's a very good question about transactional boundaries. We'll talk about that in one of the slides that will be discussed in a couple of minutes. All right, cool. So we talked about the phased approach here. Now, one of the other things that I want to quickly call out again is often organizations ignore the people, and that's one of the reasons why I selected that third story, because I think one of the main reasons was that the people were not on board, people were not collaborating, there was no shared responsibility, and at times people were worried about their jobs, and this I'm not joking, because more than one person asked, when we do this, what is going to be my role? So that's a legitimate question. So you almost always have to take the people aspect into account. DevOps is not a tool or a technology or just a process. It's all three. It's a culture. The technology and the process is there to enable the people. So you got to think about the people, and that's a key reason why this worked really well in the postal technology company. They made it a point to help the developers, to enable the developers. All right, cool. So let's go through the feature case study. I just kind of want to quickly walk through what the existing system looked like, what the target state system looked like, and then kind of show you the phased approach we took, and then we'll talk about the patterns. All right, cool. So it was a monolith app based on Oracle SOA Suite. I explained about the licensing cost, and it was reaching end of line, not easy to scale, kind of like, explain most of these pain points right at the beginning. We migrated to microservices in phases. Like I said, the first phase went in May. Now we are doing the second phase. There could be a few more phases down the line. We ended up using, there's a lot of business rules there. We ended up using rules. We have a pattern on how we can use this. Again, it's an entire different topic on its own, so I'm not going to dwell on it. We did use Apache Camel to implement the microservices. We've had a lot of success with that over the years. Test-driven development, very, very important to highlight. In all the projects that worked very well, testing was not an afterthought. It was a key part of it. In fact, we almost always took a test-driven approach, where initially it looked like we are spending a little bit extra time, but come the business end, when we are making quick changes, trying to fix issues and trying to move to production, these tests is what saved the day. And I know this is it's something obvious, should have been obvious to everybody, but often you get a lot of pushback from some stakeholders to they question the timeline, why are you spending time doing this? But it's important. It is what is going to save the day at the end. we obviously used OpenShift with pipelines, and observability, pretty key. And I'll talk about that in a slide. And that was another. It wasn't an afterthought. That was something that was there from day one. And you would notice that when you move to microservices, this is pretty important. Highly recommend to think about this right off the bat. Otherwise, you're going to be in trouble. All right, so let's put this case study into this phased approach that I mentioned. We did start with an architecture discovery session to identify the current state and the target state. Now, you can not always it's possible to run the Red Hat Migration Toolkit. This was we really had to go through existing code to figure this out. Last year we did a similar exercise where we moved some .NET-based services into Spring Boot, Java microservices. Again, had to read through the C, C++ code and some C# code to figure this out. But more often than not, if it's a Java project, you can use the migration tool. That architecture discovery sessions and the assessment really set us up. And we started, we were one of the first applications to go live on OpenShift for this particular organization. And we started out by getting, that containerization piece in place with the pipelines. We worked very closely with the team that was championing DevOps to make sure that we align with the policies. It was great. And that really set the stage for start building these microservices. Like I said, we took a phased approach. They did use a strangler-fig pattern. Obviously, it was in 3 scale. They had an existing data-powered gateway over there, and that was used to route between the new and the old. And now, yet another set of services will be cut off into the new microservices, and hopefully that pattern continues as they build more and more microservices to replace the existing solution. All right, cool. So I wanted to talk a little bit about the recommended patterns and strategies. Again, this is based on some hard-learned lessons, and I'll answer one of those questions that are in the Q&A, using these set of slides. So first thing that I want to kind of encourage people to think is event-driven. I did an entire talk on this. The video is available on our website. Think asynchronous because it really helps you design complex interactions between your microservices. If everything is going to be point-to-point REST endpoints, sooner or later you're going to end up in a big mess. With messaging, it gives you a lot more flexibility in how you do your error handling, your replay, your failover strategies. So think. Usually this is one of my go-to rules. If I can use asynchronous messaging, I will always use. I'm a little bit biased too because I spent 9 years building messaging systems at Red Hat. They really work well for high volume systems. So really think event-driven, and I encourage you to check out this talk. We talk a lot about the patterns you can use with an event-driven approach. The other aspect that I want you to think through is stateless. Think stateless. Because for you to be able to scale horizontally, your apps have to be stateless. Otherwise, you're not going to get the full benefits. And you'd be surprised how many times that we get a little bit of pushback on this. There are strategies. There are cases where you need to handle some state, and there are strategies to overcome those, to mitigate those issues. But almost always, this should be a design goal or an architectural constraint that you should not be relaxing easily, because the moment your services become stateless, you lose the ability to easily scale horizontally, and you're now throwing out one of the big advantages of being cloud native, because you can't scale anymore. Right. So the next one is observability. Distributed logging and traceability is a must. Otherwise, you're going to end up in a nightmare. You have to think about this early before it gets too late. And again, these are things that sometimes people cut corners on and pay a heavy price. And this is not this can be an afterthought. There has to be thought through. You have to have a strategy on how you're going to trace your interactions across multiple microservices, and being able to enable your operations teams to help debug and figure out issues once you go to production. So this is a must. You got to think about, again, this can be a topic on its own. Think about observability. Think about partial failures, and I think Jose asked this question about transaction boundaries. When you move out of the monolith into a bunch of microservices, there's going to be a whole bunch of failure mode that did not exist before. And this is where you'd have to design your applications for failure, your microservices for failure, and figure out how you can take compensating actions to ensure eventual consistency. Obviously, you can do transactions across a whole bunch of microservices. Prohibitively expensive to do distributed transactions. So think about those saga patterns. Think about how you can take those compensating actions when something goes wrong. This also means that though for a small window, things can be a little bit inconsistent, your state. So that's why I said eventual consistency. But by using these compensating actions, you should be able to roll things back to where it was. And hopefully I answered your your question. If not, Jose, I'm happy to have a follow-up conversation with you. Right. And think about bulkheads and circuit breakers. Very important, because you don't want your failures to become cascading failures and give you massive outages. So there's a great book called Release It. I read this a couple of years ago, and it's fundamentally changed how I think about building distributed systems. That's a great read if you're building microservices. And I think he was the person to coin the circuit breakers. Sorry, I don't remember his name, but these patterns. You would, with the postal technology company, we ended up using circuit breakers. It's important to isolate your systems or your services by using these patterns and help you insulate against partial failures. And last but not least, this, like I said, everybody wants to run applications at scale, but you've got to test them at scale. If you don't, then you are going to go into production, undercooked, unprepared, and you're going to pay the price. And automation is key here. And this is why I think the ability, so not just your applications, your test applications, your test scripts has to be cloud native as well. Your build system has to be cloud native as well. So you can really tap into the power the cloud gives you to run these test cases, these test applications at scale. That will help you really run those, not just the 1x test, but the 2x test or the 1.5x test cases, so that you are going into production with confidence. For this personal technology company, when we hit that production, when we hit that performance issue, just to be on the safe side, we ran way more than we needed. And it would have been impossible in the past. The fact that it was, like the applications, the tests were all cloud native, and the fact that there was a platform to enable that was what gave the confidence for the business owner to say, yeah, let's go to prod. I'm happy that it's not an issue. So far, we haven't had that issue because we were able to, go make those fixes with confidence. This really matters. All right, cool. I felt like I crammed a lot of stuff during this 1 hour, but very happy to have all of you. Let me have a quick look at the Q&A part and see if I can answer some of these questions. Cool. So Jose, did I answer your question properly around the transactional boundaries? If not, like I said, we can have a follow-up conversation on that. Pascal asked about, is there a way to measure the size of the solution maybe in terms of developers or microservices? Now, that's a great question. We went through several of these, scoping exercises, and what we found out was that it's for some of those large-scale migrations, it's almost impossible to assess the size, quantify the risk, and the effort. So, in a situation like this, what you could do is to take that phased approach and take on a set of features or business capabilities that you can estimate and figure out, and time box. So once you figure out how to tackle that piece, right, and do a successful migration, you can take the lessons learned from there, and apply it to another, the second phase of your project. And if you take that phased approach, you'll realize that you're going to learn along the way. The organization has the ability to catch up too, right? Because often you'd find that, and we saw this with with almost all of our customers. Sometimes the operations teams or some other team hasn't fully caught up to it, and they needed time to ramp up. They needed guidance, and some of the infrastructure pieces were not in place. So if you take that small phased approach where you tackle a small piece one at a time, now you're able to kind of time box the project, so there's no, you don't have an open-ended project with tons of risk. You have narrowed down the risk, and you can continue one phase at a time, and hopefully over a number of phases you have successfully migrated, and you have the ability to adapt to, right? Versus if you try to estimate everything from the get-go and try to figure out funding and everything, you will often find that halfway through you have made some, you're bound to make either overestimate or underestimate, and that will cause all kinds of headaches with the from the business side of things. And then John Lee asked about how do you identify quick wins when working on the app modernization. I think again a phased approach can give you those quick wins. Now, often what I found was the internal team from the customer also has to sell this to the business, right, to the business owners, and the best way to do that is if you take a phased approach and you show some quick wins, then you're able to get the ball rolling, right? You've got some momentum behind you, and you have a successful track record. Now you're moving on to the next phase, or to the next approach, right? And in terms of some of the quick wins, I'd say that like right at the beginning, see if you can containerize some low risk applications, or some applications that are easy to modernize, right? So if you use that Red Hat migration tool and point it out at certain applications, it gives you a ballpark estimate, right? Some story points, highlights what needs to be changed. Again, obviously you need to take everything into account, and you need to discuss, and it doesn't give you the whole picture, so you need to kind of fill in the gaps and figure it out. But identifying some easy applications to migrate will build confidence, will help you fine-tune your containerization strategy, your strategy around Kubernetes and OpenShift, your strategy around DevOps, right? Like how you can build these applications, and also, like I said, how you manage and scale your operations teams to kind of get up to speed and be able to handle monoliths, right? Because before they were only monitoring and managing one application, and all of a sudden you've broken it down into multiple microservices, and it can be overwhelming. And I've seen that if they were not prepared. Hopefully I answered your question, John, but again, I'm happy to have a follow-up conversation. Right, and Craig. Craig wanted to know about often have huge risks, especially in the case where documentation is limited on the source system. your phased approach fits in here to de-risk this project quick win. Oh, so this is helping me out. Thanks, buddy. Appreciate that. Yes, you'd find that especially when you deal with the legacy systems, often the original developers are gone, no documentation. But you got to really look at the source code, and even then you're not sure what's happening. So yes, a phased approach is the best approach in such a situation. Any other questions? We've got a couple of minutes. Oh, thanks, Andrew. So Andrew has posted an article on the transactional patterns with microservices. Andrew, thank you for that. I will include that when I send out the slide deck to the participants. Thank you for that. Oh, Craig has another question about where does the out-of-the-box cloud provide integration services like Azure Logic Apps, Data Factory, API fit into the toolkit and overall strategy? Why do you have to put me on the spot? But anyway, so I've had to deal with this at in my past engagements, and yes, I mean where it makes sense, you can use those. There's no hard and fast rules around what you can use. But the one thing I'd be very careful of is not tying yourself to any particular vendor, right? Because if you're vendor neutral and if your apps are not tied to a particular approach or a vendor, then you are free to move your apps to anywhere you want. So that's the one thing I'd be worried about. And instead, I would base my approach on the standards out there, right? Whether it is Tecton, whether it is Kubernetes, right? Whether it is containerization based on not on a proprietary format. And there was, before Kubernetes came, there was a very dominant cloud provider that had a proprietary format, right? And so you want to make sure that you always adhere to standards. And if you build according to standards, then you have the freedom and the choice to take your apps wherever you want. Did that answer your question, Craig?
Yes, thank you.
Okay. Oh, thank you. So someone finally spoke up. Okay. What's the most common challenge you have experienced during modernization journey across various customers? Yeah. So I think it's the reluctance to change, or the resistance to change, and this can be across. It's because people have been used to doing things a particular way. People are worried about change. People are worried about the challenges that some of the technology will bring and how it affect their jobs. So I'd say wherever a migration project or a modernization project have failed, I can almost always think of the people aspect. So that's a huge challenge, and I think most organizations that have got this right, they got it right because they had the people on board. So that's very important to have. So I think that's probably the most common challenge that I've experienced across the board, whether they are small customers or large customers. People have to be on board. People have to embrace these aspects or this new way of doing things. I think technology challenges can be overcome. You can get a vendor or a cloud provider or someone to kind of help you with the technical challenges. You can work or sometimes impose the process on people, but what you have to solve on your own is the people challenge, and you've got to solve that, because without that, it's very hard to do a successful modernization. Any other questions? Thank you all. Again, thank you for giving this 1 hour and sharing this time with us. Hopefully you found this to be useful. please feel free to reach us anytime. We are happy to answer your questions. You can email us on this email, or you can email me. Reach out to the larger Red Hat team or to us. Doesn't matter. We are happy to take on your questions, and we can continue this conversation. And I'm also offering a one-on-one with any of the decision makers. Should you wish to talk about your next modernization project, and we will work with you to make you successful. No strings attached. We are happy to talk to you anytime. So thank you guys again. Appreciate it, and see you at the next webinar. This is just the first of the series. We'll tackle some other aspects. We're talking about some other use cases in the next set of webinars, and we'd love to hear your feedback on how we can improve